This is video U2A4. Now, at this point, everything should be a review from grade 11, including this activity we're about to do. What we're doing is we're looking at friction. Now, the title is Dynamic Problems with Friction, but there are no problems here. It's just understanding friction. So your whole idea with activity 4 is to understand friction. When you do dynamic problems, we've been giving you the friction amount, but you can calculate friction. So to get static friction, and static means standing still, you need a coefficient. You look up this coefficient in a table. So if I said, for example, we have rubber on asphalt, then you could go to a table and you can look this up. Now, if you multiply that by the normal force, then you will get your static friction amount. So let's review how to get the normal force. If this is a 10 kilogram brick, we'd have a force of gravity of 10 kilograms times 9.8 equals 980 or 98 newtons. The normal force is equal and opposite to that. So if you can calculate gravitational force, you can get your normal force. So if we had a value of 0.5 for our coefficient that we look up and we take our normal force, we can now get half of the normal force would be equal to our static friction force. Now, one way you can determine the coefficient of friction is to take, I just rearranged this formula to take the static friction value and divide it by the normal force. Now, what's the difference between static friction and kinetic friction? Well, if we had a person and they were pushing a block of wood, so if this person was pushing a block of wood, the static friction would be greater than the kinetic friction. The friction is higher to get this started, and once it's moving, that friction will go down. So if you look up coefficients of friction, you will notice that this static friction will be greater than the kinetic friction. So things slide easier once they are moving than to get them started moving. Right now, what you should be aware of is the fact that if you're given a problem and you're told to consider friction and you don't know what the friction is, you can look up the coefficient on the internet, you can look at the mass of the object, and you can multiply those two to get your friction value when doing dynamic problems. A little bit of a twist. What do you do if you're on a ramp? If you are on a ramp and you're asked to calculate the friction involved of this block on the ramp, you look at what the two materials are made of. They're made of oak. Ask yourself whether this is moving or not. So if it's static friction, oak static coefficient would be 0.4. We put that in there. Because our normal force is perpendicular to the ramp and not opposite of the force of gravity coming straight down, what you have to do to get the normal force is cos theta. So cos 45, which is 0.707, times the mass of the block times 9.8. When you're on a ramp, you have to throw that little bit extra in. Now, you have an activity to do today, and basically it's pretty straightforward. All you're going to do is find the coefficient of friction of a few objects. So one thing you'll need is a ramp of some type. So for example, a cutting board or a piece of wood you've got around your house, and then you're going to take a few objects and you're going to put them on that ramp and you're going to lift it up. So imagine you've got a board laying flat on the ground with, say, a hockey puck. So a hockey puck could be one of our things. What you're going to do is you're going to lift this up until it just starts to slide. So let's say at this angle here, it just starts to move. Your coefficient of friction is equal to the tan of this angle. So you're going to need something to measure or estimate this angle closely with. And when you get that angle and you take the tan of it, that's your coefficient of static friction. Now, how do you get your coefficient of kinetic friction? It's exactly the same, but it's the angle at which this puck moves steadily, just moves steadily down the ramp. Where it first just starts to move is your coefficient of static friction, and where it starts to move steadily is your coefficient of kinetic friction. So that should tell you how to do today's activity.